Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem without a calculator. So we have 16 to the power of 8 times 5 to the power of 16 divided by 20 to the power of 15. So now what I'm going to do is I'm going to start by simplifying 16 to the power of 8. Now 16, this is the same thing as 4 squared. So now what I'm going to do is I'm going to replace 16 with 4 squared. I'm going to substitute in 4 squared. So now I have 4 squared to the power of 8 times 5 to the power of 16 divided by 20 to the power of 15. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 4 squared to the power of 8. We can think of 4 as a, 2 as m, and 8 as n. So if we want to put it in the form a to the power of m times n, a is 4, so we have 4 to the power of 2 times 8 times 5 to the power of 16 divided by 20 to the power of 15. Now 2 times 8 is 16, so we have 4 to the power of 16 times 5 to the power of 16 divided by 20 to the power of 15. Now if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So we are essentially factoring out the exponent here. So in this case, we can think of a as 4, b as 5, and m as 16. So now this will equal a times b to the power of m, so 4 times 5 to the power of 16 divided by 20 to the power of 15. Now 4 times 5, that is equal to 20. So I have 20 to the power of 16 divided by 20 to the power of 15. Now another property of exponents is that if we have something in the form a to the power of m divided by a to the power of n, this is equal to a to the power of m minus n. So in this case, we have 20 to the power of 16 divided by 20 to the power of 15. And again, we can think of 20 as a, 16 as m, and 15 as n. So now this is going to equal 20 a to the power of m minus n, so 16 minus 15. 16 minus 15 is equal to 1, so we have 20 to the power of 1, and anything to the power of 1 is itself, so 20 to the power of 1 is simply 20. Now, using these properties that I just taught you and this method, I'm going to give you guys another problem, and let's see if you can solve it. We have 2 to the power of 4 minus 2 to the power of 3 over 2 to the power of 5 plus 2 to the power of 3. So I'm going to ask you guys to pause the video and attempt to solve this problem. All right, so I'm assuming you guys attempted to try this problem. So we have 2 to the power of 4 minus 2 to the power of 3 divided by 2 to the power of 5 plus 2 to the power of 3. Now 2 to the power of 4 here, this is the same thing as 2 to the power of 3 plus 1. So I have 2 to the power of 3 plus 1 minus 2 to the power of 3 over 2 to the power of 5 plus 2 to the power of 3. And now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 3 plus 1 we can think of a as 2, m as 3, and n as 1. So now this will give us 2 to the power of 3 times 2 to the power of 1 minus 2 to the power of 3 divided by, now I'm going to do the same thing with 2 to the power of 5. However, this time I'm going to rewrite 2 to the power of 5 as 2 to the power of 3 times 2 squared. So now I have 2 to the power of 3 times 2 to the power of 1 minus 2 to the power of 3 all over 2 to the power of 3 times 2 squared plus 2 to the power of 3. Now what I'm going to do is, because we have so many terms that have 2 to the power of 3, I'm going to factor out 2 to the power of 3 from the entire expression. So I have 2 to the power of 3 for our numerator times 2 to the power of 3 times 2 to the power of 1 divided by 2 to the power of 3 is simply just 2 to the power of 1 minus 2 to the power of 3 divided by 2 to the power of 3 is 1. And we have this over, again, I'm going to factor out 2 to the power of 3. So I have 2 to the power of 3 times, now 2 to the power of 3 times 2 squared divided by 2 to the power of 3, simply 2 squared, plus 2 to the power of 3 divided by 2 to the power of 3 is 1. Now, because both our numerator and denominator have 2 to the power of 3, these two can simply cancel out because 2 to the power of 3 divided by 2 to the power of 3 is 1. So now I'm left with 2 to the power of 1 minus 1 divided by 2 squared plus 1. Now 2 to the power of 1, that is equal to 2. So I have 2 minus 1 divided by 2 squared plus 1. 2 squared is 4. So I have 4 plus 1. 2 minus 1 is equal to 1. 4 plus 1 is equal to 5. So 1 over 5 is our answer. Now I have one final problem for you guys to see if you guys can solve it. This is really a simple problem. So if you guys use the properties that I just taught you, you can simply solve this problem. So we have 6 to the power of 6 divided by 6 to the power of 6 plus 6 to the power of 4. So I'm going to ask you guys to go ahead and pause the video to attempt to solve this problem. All right, so now to solve this problem, I am first going to write 6 to the power of 6 as 6 to the power of 4 plus 2. I'm going to rewrite 6 to the power of 6 in our denominator again as 6 to the power of 4 plus 2, and we have 6 to the power of 4 here. Now remember our property that if we have a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 6 to the power of 4 plus 2, this will equal 6 to the power of 4 times 6 squared. And again, we have in our denominator the same thing, 6 to the power of 4 plus 2. So that equals 6 to the power of 4 times 6 squared. And we can't forget our 6 to the power of 4 here. Now I'm going to go ahead and factor out 6 to the power of 4 in our denominator. So I have 6 to the power of 4 times 6 squared divided by 6 to the power of 4 times. Now 6 to the power of 4 times 6 squared divided by 6 to the power of 4 is simply 6 squared plus 6 to the power of 4 divided by 6 to the power of 4 is 1. And now, because we have two 6 to the power of 4s, these two can cancel out. So now we have 6 to the power of 6 squared, divided by 6 squared plus 1. 6 squared is equal to 36. So I have 36 over 36 plus 1. 36 plus 37. So I have 36 over 37. And that is our answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 2 to the power of 20 minus 9. And we want to find out what this equals. So first off, we're going to change 2 to the power of 20 to 2 to the power of 10 to the power of 2. Remember, when we have something like this, we simply multiply these two exponents, right? So we're simply reversing that. And this is just to make it a little simpler. And we're going to subtract this with, we're going to change 9 to 3 squared. And remember, if we have a squared minus b squared, right? If we have this, this is actually equal to a plus b in parentheses times a minus b. So a in this case would be 2 to the power of 10 and b would be 3. So a is 2 to the power of 10 and b is 3. So now if we plug in a and b in this expression, we would get 2 to the power of 10 plus 3 in parentheses times 2 to the power of 10 minus 3. Now 2 to the power of 10 is 1024. And we still have our plus 3. And now we have 1024 minus 3. Now 1024 plus 3 is 1027. And 1024 minus 3 is 1021. Now what we're going to do is we're going to rewrite 1027 as 1000 plus 27 times 1000 plus 21. Now what we're going to do is we're going to distribute. So we're going to do 1000 times 1000, 1000 times 21, 27 times 1000, and 27 times 21. Now 1000 times 1000 is 1, 0, 0, 0, 0, 0, 0, plus we have 21 with 3 zeros, plus we have 27,000, plus 567, so this is equal to 1, 0, 0, 0, 0, 0, 0, plus 48,000 plus 567, and now this is equal to 1,048,567. So this is our answer.